just need confirmation from our concavity step. I'm just going to make a new page to make sure I can fit that in. So concavity times step 4, concavity. I'm looking to find the second derivative, and I'm going to pick the most convenient, best looking first derivative, which is going to be this guy, obviously. It's very simple, it's just 1 over x, based on this. That's super nice. Wow, I barely need a table, but I'll do it anyway. Can I write my bracket the right way around? That would just be lovely. Like so. Oh, it was right. Second derivative is 0. Never. Numerator is 1. Second derivative is undefined when x is 0. Now this function, it's interesting, this second derivative function, doesn't know where it comes from. It happens to come from this function in 2 steps. It doesn't know that it shouldn't be defined everywhere. It just does the thing. Hey, do with me whatever you want. I have a problem at 0. I don't really care about the rest. So I'll make my table. So you have to see it in the context of what the original function wants. On its own, the second derivative doesn't know where it's coming from. It's saying, here's the information as far as I know. Do whatever you want with that. And we have to compare it back to our original function. So these are the pieces. Splitting it up. 1 is always positive. The next piece, x, is 0 when x is 0. In the denominator, second derivative is undefined. It's going to go negative to positive. The second derivative is negative to positive. It's very simple. Now it looks here, oh, I'm bending down, I'm bending up. Yes, but remember, there are no valid x values here. So even though the second derivative says, hey, if you're interested, I'm bending down, if it makes any sense, it doesn't make any sense because of where it comes from. So, we'll say f is concave up on 0 to infinity. Do I include 0? No. It's not defined at 0. Is this an inflection point? No, for multiple reasons. It's not a point. And my concavity isn't changing as I pass through that point either because there's nothing on the left. So not much is happening. But it does say it's bending up wherever I am, which is over here, bending up throughout. So that's all the information that we have. Now let's graph it. I'm just going to make a new graph so it's as neat as possible. I know I don't really need the left side here because there's nothing there. So at 0 something's happening, 1 over e, negative 1 over e. I still have a nice critical point. Did we label that as a critical point? Yes, we did. Okay, good. Oops, this one. So I have my shape here. Let's go from the turning point up. Oh, that was very wobbly. I officially apologize. There we go. Unofficially I have to do it in these sections, otherwise my line isn't very smooth. So squint when you look at it. So there's my critical point over there. I just want to check, so I'm heading towards this 0 in a bending up manner. How should I approach it? I know it's not actually there, it's open. Like, I can't be at 0. Do I approach it at an angle? Do I approach it at a somewhat vertical tangent line, or a tangent line that wants to be vertical? Let's have a look. So let's write it on here actually. there. F of the derivative is approaching what as x approaches 0 from the right? That'll tell me how the slope behaves. So I'm looking at the derivative here. As x approaches 0 from the right, what does this mean? How does this behave? Well, 1 plus log of x is simply a vertical shift of the log function up by 1. So that means that as I'm approaching 0, so that's an extremely ugly graph. That was much better. As I'm approaching 0 from the right, I'm still going to negative infinity. Negative meaning I have a negative slope, which makes sense. Here it's all negative. It's all decreasing. But I am heading towards a vertical slope line. So I need to meet this as vertical as I can while starting from horizontal, like so. But I put a circle, open circle around there, showing that I never actually get there. So that is my graph of x times log of x, which might not quite be what you expect. Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.